Prompt Engineering Training Session 48. Calibrating LLMs. It is possible to counteract some of the biases LLMs exhibit via calibrating output distributions. 1. What exactly does it mean to calibrate an output distribution? Let's walk through a quick example. Say we have a sentiment analysis task with two possible labels, positive and negative. Consider what happens when the LLM is prompted with input, nothing sentiment. This input doesn't contain any context which the LLM can use to make a sentiment prediction, so it is called a context-free input. Since nothing is neither a positive nor a negative concept, we would expect the LLM to output a probability of about 0.5 for both positive and negative. However, often, and for this example, that will not be the case. P, positive input, nothing sentiment, equals 0.9. P, negative input, nothing sentiment, equals 0.1. Given these label probabilities for a context-free input, we know that the LLM's output distribution is likely biased towards the label positive. This may cause the LLM to favor positive for all inputs, even if the input is not actually positive. If we can somehow calibrate the output distribution, such that context-free inputs are assigned a probability of 0.5 for both positive and negative, then we can often remove the bias towards positive and the LLM will be more reliable on both context-free inputs and inputs with context. Non-technical solution. A non-technical solution to this problem is to simply provide few-shot examples where context-free exemplars are effectively assigned a probability of 0.5 for both positive and negative. For example, we could provide the following few-shot examples which show each context-free exemplar being classified as both positive and negative. Input: I hate this movie. Sentiment: negative. Input: I love this movie. Sentiment: positive. Input: not applicable sentiment, positive. Input: not applicable sentiment, negative. Input: nothing sentiment, positive. Input: nothing sentiment, negative. Input: I like eggs. Sentiment. To my knowledge, this solution has not been explored in the literature, and I am not sure how well it works in practice. However, it is a simple solution that demonstrates what calibration is trying to achieve. Technical solution. Another solution to this is contextual calibration 1, where we adjust special calibration parameters, which ensure that context-free inputs like input, nothing sentiment, are assigned a probability of about 0.5 for both labels. Note that in practice this method performs calibration over multiple different context-free inputs, e.g. input, not applicable sentiment, input, mask, sentiment. It averages the calibration parameters that work best for each context-free input to find the best calibration parameters for the LLM. Example. Let's go through an example of computing the calibration parameters for one context-free input. Note that this example is not reproducible with GPT-3 due to the fact that it can't be restricted to the labels positive and negative. Consider again the above example where the LLM assigns the following probabilities to the labels for a context-free input. P, positive input, nothing sentiment, equals 0.9. P, negative input, nothing sentiment, equals 0.1. We want to find some probability distribution Q such that Q, positive input, nothing sentiment, equals 0.5. Q, negative input, nothing sentiment, equals 0.5. We will do so by creating a linear transformation that adjusts, calibrates, the probabilities of P dot caret equals soft max, caret plus, Q caret equals soft max, W, P caret plus B. This equation takes the original probabilities, caret P caret and applies the weights W and bias B to them. The weights W and bias B are the calibration parameters, which, when applied to the context-free examples probabilities, will yield caret P caret sad face 0.5, 0.5. Another method B could also be set to minus P caret and W to the identity matrix. This method performs better on generation rather than classification tasks. Takeaways. LLMs are often predisposed, biased, towards certain labels. Calibration can be used to counteract this bias.